All right, we continue section 3.5 with vertical stretching and shrinking and horizontal stretching and shrinking. Let's look at both of these, how they look. So the first one says, suppose c is greater than 1, then y equals c times f of x is a vertical stretch. Notice c is outside the argument. And if c is between 0 and 1, then y equals c times f of x is a vertical shrink. And that's because you're just multiplying y values by c. So if a c is bigger than 1, you're stretching it. If c is less than 1, like a fraction, you're shrinking it. Vertically, right? Outside the argument, vertically. Horizontal stretching is inside the argument, and if c is greater than 1, f of cx is a horizontal shrink. Notice again, counterintuitive, right? It says like c equals 2, for example, is greater than 1, but if you see a 2 there, you're supposed to shrink. We'll find out how. And if c is between 0 and 1, then y equals f of c of x. Notice that the c is inside the argument, is a horizontal stretch. So how do you carry out those stretches? So when it's a vertical stretching or shrinking, just multiply y values by c. So if c is 2, you're doubling the y values or the vertical distances, right, up and down. And if it's inside the argument, then it works horizontally and counterintuitively. So instead of multiplying by c, you're dividing by c. If it's a fraction, you can think of multiplying times its reciprocal, right? So if I take x and divide it by half, right? If it's a fraction, if c is between 0 and 1, remember x divided by half is x times 2 over 1. So it's dividing by a fraction is the same thing as multiplying by its reciprocal. Okay. All right. So let's do a couple of these. Let's do 8a, and we'll do 8. You know what? Let's do the b's on these. So 8b and 9b. Okay. So the first one, y equals half x squared. So the half is outside the squaring, right? The half is not being squared, only the x. So it's a vertical stretching or shrinking, and I'm going to multiply y values or y distances by half. Okay, so that's all that's happening. Nothing else is happening. So I'm not shifting left or right. So my vertex, this is a parabola again. So my vertex is 0, 0. Right? Remember, it's a square. X squared is a parabola. All right, and then from there, I'm going to multiply y values by half. So 1, 1 is 1 and then half up, and to the left 1 and half up. And instead of going 2, 4, I'm only going to go half of 4 up. So it's 2, 2 to both sides. And then from the vertex 3, 9 is going to be 3 and only 4 and a half. That's 4 and a half in both directions. So 3 to the left, 4 and a half up. And then 4 to the left or right. I'm going to go 4 to the left. And then instead of going 16 up, I'm only going to go half of that, will be 8 up. So that's 2, 4, 6, 7, 8. Same thing on the other side. Yeah, there's my parabola right there, right? Just try to connect it as smooth as possible. Yeah, like so. There's my parabola. Okay? All right, what about this one? Y equals half of x squared. It's a parabola. But because the half is inside, I'm going to divide x values by half or multiply them by 2. Okay? So instead of, the vertex will stay the same because there's no shifting. So instead of saying 1 to the right or left, 1 up, I'm going to multiply the x values by 2. So it'll be 2 to the left or right and 1 up. Both directions. Instead of 2, 4, it'll be 4, 4. Notice I'm multiplying only the horizontal distance. Instead of 3, 9, it'll be 6, 9. I don't know if I have room to do that. 6, 2, 4, 6, 7, 8, 9. Somewhere about right there or so. Same thing the other way, right? Instead of 3, 9, it'll be double 3, which will be 6 and 9. 7, 8, 9. Right about there. Okay? All right, connect as smooth as possible. All right, and that was horizontal stretching and shrinking. Shrinking. Oh, this was vertical stretching. This was horizontal stretching also. Notice that both times it was a half. C was a half. But in this case, it was outside the squaring, so it applied horizontally. In this, and intuitively, that means we multiplied y values by half. And in this case, it was inside the squaring, so it's counterintuitively. So instead of multiplying x values by half, we divide x values by half or multiply by 2. All right. Let's try one other one down here. It says two functions f and g are related by the given equation. Use the numerical representation of f to make a numerical representation of g. Of g, and g of x is negative f of x minus 1. All right, so notice this says we're moving x 1 to the right, and then flipping it upside down. And flipping it upside down, you want to think of a point like the point 4, 4, and if I reflect it across the the x-axis vertically, I'm not going to go 4, 4, I'm going to go 4, negative 4. And if there's a point down here like 0, negative 2, and I want to reflect it vertically, I would move it, flip it around this way, so it'd be at 0, 2. Notice all you do is change the value of the sign of y, okay? All right, so this says we're shifting 1 to the right, okay? And how do you shift the graph 1 to the right? Well, instead of saying, let's say 0, 1, 0, 0, 0, to shift it to the right, you'd notice you would say 1, 0, right? So you're adding 1 to x if you're shifting it 1 to the right. And then the vertical reflection just flips it upside down. Okay, so I'm going to shift this 1 to the right, which means I'm going to add 1 to the x values. So instead of saying 0, I'm going to say 1. Instead of saying 5 for x, I'm going to say 6. For x, instead of 10, I'm going to say 11. In 16 and 21. Okay, and then the signs are going to change. This will be 5. You know what? I think I'm going to 5, negative 11, negative 21, negative 32, and negative 47. Okay, so notice the y value stayed the same, but just change sign. I'm sorry, just change sign, not quite stayed the same. Okay, all right, that's it. We've taken care of this. Okay. All right. Actually, we plug in some numbers. So g of 1, because g of x has g of 1, right, would be the opposite of f of 1 minus 1, right, because x is 1. So g of 1 will be the opposite of f of 0. And so g of 1 would be, and f of 0 was negative 5, so it would be the opposite of negative 5, which is 5. And you could go through and do that with each and every point. Okay. With each and every point, you could make a statement like this and just follow your statement, and it would lead you to what the y value is that you wrote already. All right, let's do one more thing, and that is what happens if we have a funky looking f. That's our f of x, right? That's what this says. Y equals f of x is that, okay? All right, and we're going to do a couple of moves. One is we're going to graph y equals f of x minus 2 and then plus 1. And we're going to graph y equals negative f of 2x. Okay? So I would like to do this one up here and then start us off on this one, and we'll finish this one in class. Okay? So f of x minus 2 means I'm shifting 2. This is a horizontal shift because it's inside the argument. And it's counterintuitive, so it's 2 to the right and 1 up. Okay? All right, 2 to the right, 1 up. And I can do that the whole graph as a whole or point by point. So if I take this point and move it 2 to the right, 1 up, it'll end up over here. That's this one over here. All right? So I'm going to start at negative 2, 2 and move 2 to the right, 1 up. Goes right there. All right? Let's call it point A. And here's point A now. Yeah. Let's call this one point B. Yeah. So where's B moving? Well, from negative 1, negative 1, it's going to move 2 to the right, 1 up. So 2 to the right, 1 up, it moves to 1, 0. And that's point B. All right, let's call this one up here point C. So that one's the same thing. From 0, 2, it's going to move 2 to the right, 1 up. So from 0, 2, 2 to the right, 1 up. goes right there. Oops, that's C. Calling it B. Hello. And then D, from 2, -2, it'll move 2 to the right one up. So from 2, -2 to the right one up, right there. This is our point D that is moved. Okay, and I'm just going to connect these. So A and B are connected. B and C. And C and D. Okay, there we go. All right, so how about -f of 2x? Okay, well, let's give ourselves some hints here. So I'm gonna half horizontal distances, right? So half divide x by 2, right? Divide x by 2, and then change the sign of y. Right? So the negative means a vertical reflection. I'm going to change the sign of y. And this is a vertical reflection. Right? And this one up here, the divide x by 2 is a horizontal shrink. Horizontal shrink, because we're dividing distances by 2. Okay, so that means our figure should get narrower, because it's a horizontal shrink, and then it should flip upside down on this one. Down here. Okay, get narrower and flip upside down. And we'll leave that one for class. Okay, all right, that's the end of section 3.5.